Well, good evening, everybody. Wanted to show you my work on the Manta and how it was originally designed, and I want to go into a little bit more detail of what I was talking about yesterday as far as the 369 and how that all works and where the uh, uh, 5.65 degree layout comes from and how all that works out. I was raised with slide rules, so the when you figure all that stuff out, you can do the math, but you have to have a reference to kind of work with, and then after that, you can work the math out, and it works out almost perfect every time. And in the day, we called it the TLAR. That looks about right. And if it fell within the guidelines of what the 369 told you, it was pretty much guaranteed it was going to be a successful aircraft. My favorite aircraft is the Mooney with the extended nose kit, the M20C with the extended nose kit. And what I'm about to show you shows you exactly why the extended nose makes it more efficient. It also indicates laminar flow wings. There's just so many things about the basic design with aerodynamics and everything that's really kind of cool. It works into building wings, just out of a piece of paper, and if you do the units correctly, no matter what unit you really use, but if you use a 369, you have a very successful model wing that's pretty stable. So that's what I want to talk to you about this evening. I laid it out, and that's what it looks like. Real simple to do. This is just 144 squares, and it's kind of fun to work with paint and stuff in the paint program, because you can fill in each one of the boxes the way that I designed that, and you can mock up anything with the base of the 369 and then add the aerodynamics to it. This was a 7-place aircraft that was modeled off of that, and modeling the manta ray. And I'm going to show you why some things work with the system. But when you have that layout, this is one of my main layout pieces that I use, and when I'm working out in the shop, I use chalk lines and everything else to get my basic design, pop it off that, and I can do my lofting from that. It's a very efficient way to build things. We'll take this off and move it to the side, and I'll get more of my presentation here. Of exactly how all that works. This is electric aircraft is a thing I've been working on since the 70s. It's been a dream of mine, and this particular unit, when we laid it out, and I can't believe that somebody found out what I was working on back in the day, why it works and how it works. But it's pretty neat. As y'all know, if you're working with aerodynamics, you have your lift, you have your weight, you have your drag, the direction that you move, and then your angle of attack. Okay. And what's really neat about this concept is when you use a thrust fan motor for vertical takeoff, it actually keeps the wing from stalling, and then you have the lift, and you're actually using that airfoil as part of the system. Okay. And the same thing in forward momentum, it automatically makes like a biplane, and so you actually have more wing area than you suspect there in level flight. So you can use much shorter wings. And we originally went with the 10-inch design, and the reason was with CFM, and that gets into ductulators, and I'll go into more of that. Some people understand CFM, cubic feet per minute, and then your velocity, feet per second, and then you target your what your speed is to do that. Now, the cool thing about electric motors is that you can overdrive them, okay, and your battery pack will run down, but you can run independent motors faster, and you actually have full control of a platform by doing that. And a lot of people that work with drone industry know exactly what I'm talking about, but you have perfect control centered with that. And so with the system, you can actually remove control surfaces by motor speed. You can handle your pitch, you can handle your yaw, and you can handle your bank, okay, your roll axis. So you can control all the axes by this configuration with the unit. So you can do away with control surfaces. Pretty slick, huh? The back in the day, when motors were being done, they were wanting to go 2-stage, 1-stage, and we found that, you know, below 14,500 feet, a single stage is perfect. The thing that's really cool about this diagram that I originally showed you, kind of looks like a hand grenade with a 369. What do I do with it? Anyway, it actually indicates the pitch of the propellers for your speed with it, and I'll show you more about how that works later on. We went with 10 inches because it just seemed to really work well, and so your canard up front 60 inches, and depending on how you do your wings, if you have 12 of them set up, that's 120 inches basically in the setup. And we kept fudging more and more. The bigger the duct, to a point in that small design, was really cool is as far as the physical material that's in one of these units. Okay, I'm talking about at the commodity prices. There's not $30 worth of material at commodity prices when you when you build that. Of course, you know you can sell these for $3,000. You can sell them for anything you want to, but as far as the commodity pricing of what's in there, just to get it straight, you're talking about $30 per unit as far as raw material cost. Okay, of course your time and everything is worth something, but they can be mass produced very easily, and you know for the design, once they're all set up, I can easily see those selling for about $100 each. So if you have 36 fans, that's $3,600, right? Okay. So the cost is not really much in there, but this actually gives you all your blade angles when you triangulate off of it, and it's pretty neat to use. Now, we called it the Manta. There's a company in Germany that's calling it Lilium, and they're a $1 billion company as far as worth. They've done a good job with the technology. I can make it better, longer flight times with my technology, but again, based off the Manta. the edge of it, like I said, this makes like a canard when it's, a biplane when it's designed correctly. So you have two lifting surfaces when you design it correctly there, plus the benefit of using the airfoil in front of it as lifting too. So you get quite a bit of increase depending on the flow type you build, anywhere from 18% we saw in the lab down to 6 and 7%. But it is more efficient to use this configuration. And that's the reason I worked so hard on the Mogen, because I didn't know anybody had come out and actually taken this technology. Like I said, we were working on it back in 2004, 2005, 2006, in that area as far as the concept. But I wanted to show you exactly how we laid it out originally and how it fits into the parameter of what it is. Okay. That's a rear view. Now, something that they've done is they've added cutouts, and that's something that we never thought of. I really don't know why it's they're there. We were using basically a tube for doing that, so they must have found something as far as stability. I have to look at that. So they've done some further work than what I was aware, but the very simple system, not much to wear out. And it's the project I've been keeping in mind for the Mogen and getting the flight times up there. Kilowatt hours is kilowatt hours, and you can extend the run time, but there's no free lunch. Now, like I said, the density batteries that they're using, which I imagine they're using lithium ions, the Mogen won't work with that system. But what we can do with the Mogen system and the type batteries that we're using, we can actually build them into the structure. The canard up front, and you have full control of that for your vertical takeoff, vertical landing, and other transitions in your profile. Again, based off the manta ray, and those dimensions pretty much fall right within the cone that I was showing you about. Really, all the axis with it does. They shortened it up from what we originally had it. We have it a little bit longer. Beautiful plane to build a model of. I would suggest any model enthusiast really go out and research and get the pictures of it, draw it up. One of the things that I always suggest with a new project is model building, have other people do it, and they all come up with the different tricks to make it so much better. Also, the flight simulators can be geared up to do that. So I'm calling it the Manta. They call it the Lilium. I'm interested for my own personal aircraft. I'm not trying to go in mass production or do anything what Peter Muller's doing with Raptor. But one of the reasons I did contact him was because I wasn't familiar with the Lilium project, but his basic profile with his molds looked like something I could build my batteries into, and really wanted to contact him to do that. You can see it's kind of like a hammerhead shark front end, plenty of room in the unit. Originally we were working with about a 4.5 foot wide cockpit. Lays out very well. the landing gear is something I'm going to get into later. I have a better landing gear system than anybody got out there. It was designed for this, but it's very simple. When you see it, you go, "Why didn't I think of that?" But I'll be getting into the landing gear system that we worked out for this project. The undercarriage, the nacelles actually hinge on each unit, and as they come up, you'll notice that airflow is forward, just like on a biplane. Okay, and so the suction coming up, and that's probably the reason that they put these units in, is to make that a platform as a nacelle in itself. So we didn't have any of those configurations on it, like the bat kit wires. You can see the nacelle. Now, if you think about it, that's 10, 20, 30 inches, okay? And so these nacelles, at the time, we were looking at putting 3 per unit, and they were 10 by 12 nacelles. So it gives you a pretty good idea of how that works as a control surface. And then there's 2 of them on the front canard. So you actually have a very good reference point. Is, you know, that's just a little over 5 feet, okay? And so pretty simple to engineer it. One of the beauties about it is the redundancy of the system, and properly designed and configured, if you're not real overweight, you're still flyable, and you may have to land at an airport instead of a vertical takeoff and landing, but you can lose quite a bit of the system and still be in operation. I just wanted to show my basic, I call it my 144 or my 44, and I have an 88 and right on through that I designed with. One of the cool things about it is that I can color in the pixels off of the 369 design and have my basic layout, and then I can draw my lines and everything in there. And that's the way I've been doing it for years, guys, whether it's on paper or with computer. I'm not a CAD guy, okay? I always drew up the stuff by paper and showed the guys what it was, and I have other people put it in the SolidWorks, AutoCAD, and other things. I don't have enough patience for that, but with my methods, I can do a layup really quick without ever having to put it in a computer model, and I'll know it'll work. Okay, it works like a slide rule, and it's kind of like one of those things that you can recreate and do over and over and over again. That's the Manta, and we had it set up for a 7-place aircraft, and that was the original 7-place aircraft in what we did back in 2003, 4, in those areas. I hope you enjoyed the presentation. Now, I want to talk to you a minute about empty shell weight targets. For a 2-place, the empty shell weighs 350 pounds. Okay. Now, what's really cool about that is if you're doing carbon fiber, you can produce carbon fiber for about $10 a pound. Okay. That's one thing great about fiberglass. Fiberglass is about $2 a pound, hadn't changed a lick. So if you're figuring on building, with fiberglass, it's about $2 a pound. Finished product, carbon fiber runs about $10 a pound for carbon powder. Four-place runs about is 450 pounds. Okay. The original service ceiling was 14,500 feet on the original designs that we studied. The target cruise speed was 185 miles an hour, or 161 knots. The target descent cruise was 210 miles an hour, 182 knots. Never exceed speed was 210 knots. Okay, so it had a capability in a descent cruise. We designed it not to exceed 242 when we were doing our original designs. Of course, our target flight time is 6.75 hours. So the lift to drag ratio, empty weight, design empty weight, lift to drag ratio was 21 to 1. Of course, all that changes with passengers and other things in there, but your empty weight was designed 21 to 1. The full flight weight design was 1,500 pounds for a two-place, and for a four-place it was 2,000 pounds. The max power propulsion required for the two-place was 288 kilowatts. That's equivalent of 384 horsepower. Okay. For the two-place was 340 for the four-place, which is equivalent of 453 horsepower. So, just wanted to throw that up to you. The airframe only with a 12-hour battery pack for the interior, exterior lighting, seats, controls, avionics, landing gear, no propulsion or engines, motors, propellers, turbines, propulsion, battery system, fuel, oil, electrolyte, cables, or propulsion controllers. That's the empty shells that we're talking about for the two-place, weighing 350 pounds, and the empty shell for the four-place, weighing 450 pounds. So, in other words, that's the actual carbon fiber of what we thought when we did the original takeoffs. And with my experience now with the carbon fiber, that's very achievable. So you can get those weights down. Carbon fiber is an amazing product. The batteries, fuel propulsion, cooling and heating weights, and that's one of the nice things about it is that we have discovered a way to run motors that they actually run cool. Okay, we did have a problem at first when we came out with the Mogen, that we were having to oversize the wiring and everything, and then we figured out about 2.5 years ago how to run cold current and put it right there at the motor. So we've overcome so many things. Still got a long ways to go, but the total batteries, fuel propulsion, cooling and everything, two-place was 650 pounds, four-place was 750 pounds. Okay, so that's your power system that you're allowed. I always tell people, yeah, we can do it for under a half ton, but you have to remember, with the system that we have in the current state, it still has to be maintained, and the batteries have to be refreshed. And when you do the math on it, the Peter Muller's Raptor with the Audi 3-liter TDI diesel engine with the redrive system that he's using, you can buy a whole lot of diesel for what you can do an electric powered unit at this point. Okay, it can be done. We missed the target weights for the propulsion system to this day by 600 pounds. Okay, so we've got on the propulsion system, we still have to lose 600 pounds for the targets that we originally set up for this. The 10-inch ducted fans power to thrust ratio and energy consumption look the most promising in several regards. At thrifty price, like I was telling you, system redundancy, battery management system, your power hookup and your terminations. The in normal usage, they have a pretty good range with what we design, from anywhere from 60 pounds of thrust each to about 40 pounds. So if you throw the current at them, they'll do more than what we want. The target goals that we're really wanting to achieve is 9-to-1. Okay, and the thrust ratio, 44 pounds at 4.44 pounds is the thrust ratio. That's our target, with about 9.44 kilowatt usage per unit. That's about 12.5 horsepower equivalent each. Okay, so to understand this technology of multiple power drives and lift equipment, there exist many tricks of trades of engineering, wing lift, Bernoulli's force, and there's many applications that most flight engineers aren't aware of, and for fixed winged aircraft. And we, like I said, we were pioneering this type propulsion system years ago. And this is where my company fills in the gaps, is we have figured out so much. Now, I've shown you a trick of the trade I haven't really shown anybody in the world. They go, man, you must be one hell of a mathematician. No, I just know the layout and know how to build it that, and then you can check the math with it, and it works. Okay, I always told a story that I don't believe Albert Einstein ever created anything. He was a good mathematician, and he knew how to work the mathematical terms, but he had a picture he was working off of from guys like Tesla. Okay, and I'm the one that I got the picture. I learned how to do that years ago, and then I do know how to do the math to back up the numbers. So that's going through there. So aircraft is my hobby. I always told people with aircraft, you can throw all the money you want to at the ceiling, that sticks you get to keep with aviation. I'm a commissioned research and developer for alternative energy projects. I've been full-time doing that since 2015, and I was working on it way before then when I was doing my jobs and everything else. And thank God I've been able to turn this into my work. You know, it's not working. It's a pleasure to do what I do. I enjoy every minute of it. I'm a founder of Solar Art, the Mogen, metronomic parametric battery management systems for off-grid UPS systems. And off-grid UPS has been a whole lot. Pumping water for swimming pools is where we prove the 1.5 kW unit. I don't sell anything to the public. The other manufacturers take those, and so I'm not in the business to do that. Others do that. Okay. But when the mains go off, it's pretty nice to have power all the way through without the noise of combustion engines, and we've learned to do that at the 15 kW level. The equivalent of what we have with the Mogen system is like having 3.2 megawatt battery management system, which is 9 days runtime. Now, let me explain something. Okay, the Q goes way up. It's all about battery management. Okay, and so as you ebb and flow through your time with your usage, but I promise you it drops to 6.75 runtime hours at full load capacity. If you've got a high Q, it's not a free lunch. And I've always told people your cheapest power is off the poles and wire, so there's no free energy. However, the inverter that we helped develop and the battery systems for that, it's the most powerful inverter in the 15 kW world that there is, split phase in the 120 240 volt system, 50 to 60 cycle system. Lots of work went into that. COVID changed a whole lot of things, and the a lot of the suppliers that we were sending customers to was China, and since COVID has happened, the didn't think it was a good idea to live here in America and trying to get everything as much as we can reformatted for the USA. So it's a tough thing to do. It really is, because a lot of people, when you're talking about these type systems, don't even have a clue what you're talking about. And other people throughout the world, they've been dealing with these technologies for a long time, and so they know when you ask for a specification. And but we're on board with getting everything manufactured in the United States. The picture that I showed you, when you do the layout, it works automatically. I hope this helps you. I hope you enjoy my video. I'm not trying to gain a lot of followers or anything else in those realms. I love helping people. I have a lot of experience, but the aircraft, that's for my own personal pleasure. I'll do it, but not interested in building a prototype or taking orders in that way. I'll leave that to guys like Peter Muller and those guys. I'm just I'm good with my hands, and had a lot of different trades, everything from automotive. Boats have been my specialty since 2008. They call me the Boat Yoda. And props and propellers have always been my forte. One thing I am looking for is somebody out there really knows air props. I know water props, okay, but somebody really knows air props. The cone of thrust we do with boat propellers all the time. We don't have that that I've been able to find, and I've asked some pretty smart people, and with no response. So if anybody can lead me to that information for air props, cone of thrust, and what's the trick to those designs, is probably in that layout. I just hadn't quite figured it out yet on as far as air props and cone of thrust. That's something that pretty much I haven't done the research on yet for development, but somebody has information on that that's good enough information. And we're going to talk about props and layouts of props. I used to whittle my own props for my my airspeed stuff, but I had a real simple layout for that and knew exactly what I was doing. But we can talk what's going on with that. But those days with air props, I've always just left that to Hartzell and all the other guys as far as power on the front end of real airplanes. However, I think that needs to be revisited, because I think we can get much better efficiency with props, and people understanding why and what the difference is and what it does, and better in performance. So anyway, I hope you guys are having fun, because we are, and I'll see you next trip. Bye.